Okay. So here's how we do example 1. Example 1 wants you to shade the appropriate stuff. And the first thing we want to do, I guess, is label those circles so we know which one's which. So let's call this A, B, C. And now the way I do them, I start with the first set of parentheses here. I need to shade the intersection of A and B because that little upside down U stands for intersection. So right now, go and shade the intersection of A and B. So here's A and B. The intersection would be everything that is in both A and B. So there's the intersection of A and B. Just like this example here. Okay, then it says or. So this little symbol, the U, that's an or. Or means to add everything else or everything that's in C. So let's go shade everything that's in C. So I guess this is everything that's in C. And since you're looking for the union of my first shaded region with the second shaded region, the union just means everything. Like everything that's in the first shaded region plus everything that's in the second shaded region. So the final answer should be everything that was in the first region plus everything that's in the second region. So that's the final answer for number 1, I guess part 1. And like I said, I didn't put this on the test and quiz because it was just not easy to do online. But just practice anyway. Example 2. I need you to shade A and B complement. So you need to shade everything that is not A and B. So first, let me go find A and B. It helps if you label everything. So A, B, C. I'm going to go find A and B. So I guess A and B would be what's inside of that intersection, but you want to shade the complement. So that means you want to shade everything that's not A and B. So that means we want to shade like everything outside of that, including like the square. So your answer would be everything but the intersection of A and B. So do it. Shade everything. Here's a everything. That's number 1, part 2. And let's try it one more time with the third diagram. Let's shade A or B. So the first thing is A or B, so a union of A or B. So that means everything in A or everything in B. So basically everything in the circles that are A or B. Okay, but here you have to do the intersection now of not C. So for starters, let's find the complement of C. So here's C. And I would have to shade the not C. So it would be like everything that's outside of C. Okay, now I have a big mess here, but right now I have like everything on my first shaded region plus everything on the second shaded region, but this is an and symbol. So for that and symbol, you need to find the intersection of both of those shaded regions. So I guess you have to go figure out where did the first shaded region intersect with the second shaded region. And since it's a big mess, I think it's going to intersect everything that's inside of A or B, but it has to be outside of C, so we can't have that. I don't know what that is. So here, the final answer for that one has to be everything that's outside of C, so it has to be outside of the circle C, but it has to be inside of the A or B. So everything that's on the outside of circle C, but it has to intersect with the circles A or B. So that was the most challenging one, but it's not on the test because I just get
Nothing is inside circle C.
Nothing has to be, no, it cannot be inside circle C. So Pause for questions. All right, example 2 is for sure one of your questions on the test, so make sure you know how to do it. Example 2, use a Venn diagram to solve the following. Read the question. Okay, so for this one, we're going to have to draw a Venn diagram of the 3 events here, which are red, blue, and green. So, red, draw it, and that would be like, I guess, what you would show for work. Even though we're not even showing any work, we're just typing in answers on the test, but that's okay. Okay, so here's my Venn diagram. R stands for red, blue, green. I can't spell green. So now you're going to have to read the information and start filling out the little numbers inside of these circles. And I always like to start with it's easiest to start in the middle. I start with how many people liked all 3 colors, because then you can start working outwards from there. So it does say 22 people liked all 3. So we're going to put a 22 right there. 22 people liked all 3 colors. So start with that on the test, start with the middle. And then you can start subtracting and start working, I guess, outwards, which means, let me read what it says. The number of people that liked blue and green was 64. Blue and green. So this right here, that represents blue and green, and that should be 64. But we already have 22 in the middle, so take 64 minus 22 so you can find how many people here liked blue and green but didn't like the red. So let's do 64 minus 22. Is it 42? Okay. 42. So make sure you know what the 42 represents. 42 represents the number of people who like blue and green, but they didn't like red. So 42 represents people who like blue and green, but did not like red. 64 total liked blue and green altogether. And then just keep going from there. 37 people like red and blue. So this is red and blue. So 37 minus 22. 15. Again, 15 is the people who liked red and blue, but not green. 90 liked red and green. So 90. So this is 90. So 90 minus 22. 68. One more time, make sure you understand 68 is the number of people who liked red and green, but not blue. And still keep going. Now let's do 150 liked green. So that means like the entire circle here for green. That entire circle should be 150 people, but we already have the 68, 22, and 42, so let's go ahead and subtract. So take 150 and subtract all these little numbers so we can find out how many people like the green only, like only green. So 150 minus 68 minus 22 minus 42, 18. And again, make sure you understand that the 18 represents the number of people who like green only. Green only. The entire circle for green is 150, but that includes people that like everything else. Keep going. 123 is blue. Here's blue. It's 123, subtract 15, 22, and 42. So subtract the insides. 15, 22, 42. 44 people here liked blue only. And one more time, 138 for red. This whole thing should be 138. Yeah, this is definitely, like I said, one of the questions on the test. 138 minus the insides, 15, 22, and 68. $33. And those are the people who liked red only. And now that you have all that big mess, now you can start actually answering the questions. Letter A. How many people liked red and green but not blue? Red and green but not blue. That's the 68. And these are fill in the blank, so you just type in 68 in your blank for the test. How many people like green only? We already told you. 18. Green only. And finally, letter C, if there was 250 people, how many did not like any of those three colors? So again, get the calculator ready. So we're going to have to add everything, like all these little numbers, the 33, 15, 44, 68, 22, 42, and 18. Add all those numbers and see how many that adds up to. And if that's not 250, then that means that there's some people that didn't like any of those colors. So add them all up. 33 plus 15, probably, plus 44, plus 68, plus 22, plus 40. 242, correct? So since all of that added up to 242, but the question says if there was 250 people, then that means that there are 250 minus 242 is 8. There are 8 people who didn't like, no, yes? 8 people, right? Okay, so I think my answer key is wrong, because on my answer key I put 18 on the answer key, so that would be wrong. Fix it. It should be only 8. So that's a little mistake on my answer key. So it should be 8 people that did not like any of the colors. Pause for question. All right, example 3. First of all, here's a huge, gigantic formula on how to find the union of 3 events. So like if you want to find the probability of A or B or C, you would take everything that is in A plus everything that is in B plus everything that is in C, and then you have to start subtracting some intersections because they get double counted, they get counted twice. And then at the very end you have to add the intersection of all 3 events because then it gets counted all. You just have to do it. This formula, make sure you memorize it. That's not given to you anywhere. So if you do see a question like that on the test or quiz, like example 3, you're going to have to memorize that formula in order to apply it. So number 3, use the addition rule, which is up here, to solve the question. A question is sure that 19 people like A, 18 like brand B, 20 like brand C. Okay, just read it to yourself. How many people were there? So we're trying to figure out how many people were there all together. So basically we're looking for like I guess the probability of A or B or C. We just want to add everybody that liked A plus everybody that liked B plus everybody that liked C, and we want to figure out how many actual people there were. So I'm going to use the formula that is at top. I need to take everything in A, so 19, plus everything in B, so 18, plus everything in C, 20. But you have to subtract intersections because sometimes like people like both A and B, and you're counting them twice. You're counting them once with the A and then you're counting them once again with the B. So we have to subtract the intersection of A and B, so 5. Same thing with the B and C, so subtract 8, and A and C. So subtract those intersections so you don't count them twice. But finally, if you do subtract those intersections, you actually end up subtracting the middle, the people liking all 3. You end up subtracting that too many times, so we have to go back and add it. 2 people liked all 3. And that should give us our answer. So if you plug that into the calculator, that should tell you how many people there were all together in the survey. 19, 18, 20, 5, 8, 7, plus 2, 39. I feel like there is one thing like that on the test, and it may be multiple choice, so make sure you go back and look at it. Pause for questions. Alright, so the last thing you need to know for today, besides the Venn diagrams, please make sure you're familiar with examples 2 and example 3. You'll see those on the test. The last thing you need to be familiar with is something called permutations and combinations, and we're going to use the calculator for everything because stats is 100% calculator. So I'll show you how to do those. You just need to understand the difference between a permutation and a combination. In a permutation, the order of arrangement matters. So let me write it down. I don't know. Permutation. Permutations. I always just say order matters. So that, like, the order in which you arrange the items matters because it produces a different result. So anytime a question says like you are arranging books on a shelf, like math, science, social studies, is different than if you start with social studies, math, science, whatever. So any kind of arrangement, so if you see words like arrangement, or if you really see the word like order, those are all permutations where the order will matter. And then the other type of thing is called a combination. Combination. Those, the order doesn't matter. Does not matter. So for those, the order won't matter in your results. And those kind of questions are usually always asking you like how many ways can you select a committee or selecting people. I'm just going to put like selecting. That's usually what they're asking for, like how many ways can you select a group or something. But the order won't matter. So the hardest part is determining the difference between the permutation and the combination, and then after that is just put in the calculator. So let's try number one. Number one. It says for each of the following, determine how many outcomes there would be by using either the permutation or the combinations on your calculators. Number one, a pizza with 4 toppings from a menu of 8 ingredients. Okay, so for that you have to think about the pizza. Like, it won't matter how you arrange your toppings on the pizza. Like, you're still going to have like a pepperoni, sausage, and spinach pizza. It doesn't matter which order you put the ingredients. It's still the same pizza. You're still eating like a sausage, pepperoni, and spinach. So for this, for the pizza, it's going to be a combination. Combination. Because you don't care how the ingredients are arranged. Like, you're still going to eat the pizza the same way. So the way you do that is on your calculators. Okay, you need to find a calculator. Oh, okay, hold on. Pause. Okay, so hopefully you have a calculator so I can show you combinations. And this is, that's pretty decent. All right, so on the calculators, go to menu, probability, and then there's a button that says combinations. So find it. Menu, probability, combinations. And it just comes up with this NCR thing. Let me show you what the notation is for this NCR. So here, for the first thing, you're going to put the total options, comma, then the ones that you want. Here, let me tell you what that means. So for this pizza, the total number of options that we had to choose from was 8 ingredients. So 8, comma, and then how many ingredients are you actually selecting? It says 4. So then you just press enter. And the answer is 70. It tells you that there's 70 pizzas that you can make that have 4 toppings if you're choosing from a list of 8 toppings. So you would just type in 70. Technically for your work, like if this is the real AP exam or for response, for your work you can just type like combination 8, 4. You can just type it like that, like C, or show your work, I guess, on paper. You can just leave it as the C 8, 4. Or you can do the NCR 8, 4. They're both the same. Oh, don't forget to actually give me the answer. 70. I forgot the answer. So the actual answer is 70. So type in 70 on the test. You don't have to show me your work. So that's number 1. So I'm going to give you like a minute. Actually, let's try number 2, and then I'll give you some time to try a few of these by yourself. If you notice number 2, okay, the question already says the words arrange. that's automatically a permutation. You want to arrange 6 books on a shelf. So the arrangement will look different, like if you arrange your math and your science and your English and your, I don't know, Spanish book versus if you change the order, it will look different. So it's a different outcome. So this is called a permutation. Go look on the calculator. Menu, probability, permutation, and it works the same way as the combination one. So for those you have NPR, and then you have the total, comma, what you want. So it looks like on number 2 you are arranging, you have 6 books and you are arranging all 6 of the books. Like it just says arranging 6 books. So you want to put 6, comma 6 because you have 6 books and you're going to arrange them all 6. 720. So for my work, I can put 6, comma 6, 720. So I guess this would be the final answer. Number 2. Okay, now here, try to do number 3 by yourself. Right. So for number 3, you should have done a combination because you're just selecting friends to go with you. You're not ranking them in any sort of way. So you have 6 total friends to choose from, and you're going to pick 2 of them. So you just put that in your calculator. Menu, probability, combination, 6, comma 2. And that's 15. So there's 15 possible ways of group of friends you can take. 15 ways. That's number 3. When you get to something like number 4, you can still use the combination or permutation situation here. On number 4 is asking you how many different 4-letter words that begin with a vowel can be made from these Scrabble things. So this is going to be a permutation. Number 4 is a permutation because you are arranging tiles and they will look different if you put like ABC or BCA or whatever. So it is a permutation. And you can do it with the permutation, with the little NPR thing. But when it comes to questions like number 4 in specific, that goes up there. When it comes to those, instead of using the permutation, I use what's called a counting principle, which is the same thing as a permutation. But here is what the counting principle does. Let me put that over here, selecting. So here goes. In a counting principle, you do how many 4-letter words. So I'm going to put like 4 little blanks that are going to be multiplied. 4 little blanks because it's a 4-letter word. Can be made beginning with a vowel. So that means that for my first blank, the word has to start with a vowel. So you look at your choices and you count how many options do you have that are vowels. So I have A, E, O. So that's 3 choices. And once you use a tile, you can't use it anymore because it's Scrabble tiles. So now, it doesn't matter which one you chose, the A, the E, or the O, but we need to take it out. So let's pretend it was the O, so now we take it out. Now for the next tile, for the next word, I guess, you only count how many tiles you have remaining. You have 1, 2, 3, 4, 5, 6 tiles remaining. So 6. And it doesn't matter which one it is, but once you use it, you can't use it anymore. So pretend it was a G. For the next tile or for the next word, you only have 1, 2, 3, 4, 5 tiles remaining. And finally, for the last one, you only have 4 tiles remaining. So that's one way to do it. That's called the counting principle. Multiply that out. It looks like 360. Or if you prefer to do the permutation thing, you can do the permutation thing if you wanted. Here's what I would do for the permutation thing. I would do a permutation of 3, 1 first because the thing has to start with a vowel and there's 3 of them. So 3, choose 1 times the rest would be, once you choose a tile, remember how once we chose 1 vowel, there was 6 tiles left. 6, 3 because there were 6 tiles left and we needed 3 to finish the 4-letter word. So if you do that on your calculator, it still should give you 360. So do that. Pause for question. Let me see. Pause for. Continue. Number 5. An outfit of jeans and shirt that is chosen from 5 jeans and 9 shirts. I don't know. This is where, like, if you want to figure out how many total possible outfits there are here, I would just use like the counting principle. You have 9 options for a shirt, so I guess like 9. And you have 5 options for the jeans. So you could just do 9 times 5, 45. Or I guess you could do like a permutation, like a 9 permutation 1 and a 5 permutation 1 and multiply them, but I would just use that. Either one's correct. Number 6, a group of 10 is lined up for a picture. You want the tallest 4 people to stand in the back. So people are lining up for a picture. Oh, line up is another one of the key words for permutations. Like when you're lining up people to take a picture, or when you're lining up kids at the lunch line. When you're lining up people, those are permutations because the order will matter. The way you arrange the kids to line up for lunch, it does, or recess, whatever, does matter. So this is a permutation. You can do with the P permutations, or this is another one of the ones that I like to do with the counting principle, because it says I'm going to arrange 10 people. So I guess I could have like 10 little blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm arranging 10 people. The tallest 4 have to sit in the back. So somehow, let me just pretend this is the back over here. Over here in the last 4 spots, which is the back, you have to put the tallest 4 people. So that means that I'm going to put 4 for like the tallest 4 people. I have 4 options. And then 3, 2, 1. So this is me arranging the tallest 4 people. So I'm going to ask, okay, where are the tallest 4? And then I'm going to put them over here. Put the tallest 4 people here. 4, and then 3, 2, 1. So those are the tallest 4 people. And then finally, for the rest of the people, there's 6 people remaining. So you have 6 people to choose from. 5, 4, 3, 2, 1. If you do it like that, it's going to give you the total options for the number of ways you can arrange this. Multiply it out. Or if you prefer the permutation thing, you can just do 6 permutation 6, 1 times permutation 4, 1. They're both going to give you the same answer. Just type in the calculator. Permutation 5. 1 times permutation 4, 1. Final answer, there's nope, that's wrong. Oh, it's not 6, it's not 6, 1, it's 6, 6, because you have to arrange all 6 people for the picture. Same thing here. It's not 4, 1, it's going to be 4, 4, because you have to arrange all 4 people for the picture, total of 10 people. Now that gives you the right answer. So, which is like 17,000. Yeah, 208. Okay. Pause for questions. There we go. Okay, so that's definitely the one you need for the test, because that's the only one I put out of after all of these permutations. So number 7. I need more paper. The math club is making a 5-person team, because we do actually compete in math, okay? We are state champions. Okay, there are 6 freshmen and 10 non-freshmen that they can choose from, because they have to try out. Letter A, how many teams can be formed? So because we're just forming a team, this is considered a combination. This whole thing, number 7, is considered a combination. Because we don't care like the order in which we select them, we're just still going to have the same team, the team. So, number 7, letter A. How many teams can be formed? So that means that we're going to do a combination. And remember, for the combination, you need the total, comma, and then what you want. So we have a total of how many people to choose from? 10 plus 6, 16. But we only want the team to have 5 people. So there you go. That's going to be the first answer. You do a combination of 16, 5 to figure out how many possible different teams the math club can create, choosing from 16 total people, and you only won 5. So type that in. Yeah, 4368. Yeah, there we go. So that's the total number of teams that the math club can create. Good, perfect. Letter B. How many teams can be formed that have 1 freshman and 4 non-freshmen? So we need to start splitting this up. It's still a combination because we're still just making a team. So you want your team to have 1 freshman. So we're still going to do a combination. This time, though, we need to select only 1 freshman out of the total number of freshmen that we have to choose from. There are only 6 freshmen to choose from. So you're going to do combination 6, 1, because there's a total of 6 freshmen and you won 1. But then that's only 1 person on the team, so we still need to multiply by the number of non-freshmen that we're going to have. So how many non-freshmen are there? 10. Comma, now think about how many non-freshmen we need in order to make a 5-person team. Perfect, 4. So if you multiply that out, then you're going to figure out the number of teams that will have 1 freshman with 4 non-freshmen. Times, make sure you put times. 1,260. Perfect. Got it. Letter C. So letter C is asking for a probability. And what is the probability that the team that they select has the 1 freshman and 4 non-freshmen? So basically, we have already our answer here. So for probability, we just need to take a numerator over a denominator. So the numerator should be what we wanted. We want our team to be 1 freshman and 4 non-freshmen. So we already have it on part B. Those are the teams that have 1 freshman and 4 non-freshmen. Out of the total number of teams, so remember letter A. So this is going to give you the probability of you the math club selecting a team with 1 freshman and 4 non-freshmen out of the total group of students that they have to select from. So if you do 1260 over 4368, 0.2888, yeah.
Do you write the decimal?
Remember to, for the test, follow the directions. I'm pretty sure on the test it says only type the 3 digits to the right of the decimal. So I guess you would be typing 288. So definitely on the test, letter C. Keep going. Almost done with this video. Letter D. Okay, we still have time. Letter D. How many teams can be formed with at least 3 freshmen? Okay, so this one's fun. We need to have at least 3 freshmen. So that means that your team could have 1 freshman with 4 non-freshmen, or the team could have 2 freshmen with 3 non-freshmen, or because this is at least 3. Oh, just kidding. I can't do math. Oh my god. So at least 3 freshmen means you have to start with at least 3 freshmen and 2 non-freshmen. I'm still doing pretty good. Plus, the team could have 4 freshmen with 1 non-freshman. Remember, the team is only 5 people, so it has to add up to 5. Or the team could actually be 5 freshmen with 0 non-freshmen. So I think these are the only possible ways to have at least 3 freshmen on the team. So 3 freshmen with 2 non-freshmen, or 4 and 1, or 5 and 0. So now we have to figure each one of those out and add them all together. So let's start the first one. Let's figure out how many teams have 3 freshmen and 2 non-freshmen. So for the team to have 3 freshmen, you do a combination of, there's a total of 6 freshmen and I want 3. Times, when you do a times, because we still need to select the 2 non-freshmen. 10, 2. So let's slow it down and see. This first set of work here, this represents a team that has 3 freshmen out of the 6 total freshmen, and it has 2 freshmen out of the 10 non-freshmen, or 2 non-freshmen out of the 10 non-freshmen. So that's the first, that's one possible way. Or means to add. Or let's figure out all the number of ways that we could have a team with 4 freshmen and 1 non-freshman. So that's going to be 6, 4 times 10, 1. Again, this represents having a team of 4 freshmen out of the 6 freshmen, selecting them, with selecting 1 non-freshman out of the 10 non-freshmen. So this is going to give you a team of 4, 1. And one last option, the 5 freshmen and the 0 non-freshmen. 6, 5, so selecting 5 freshmen out of the 6. And I guess you're selecting 0 non-freshmen. That's just 1. So if you want to, you don't have to do the 10, 0 here. That's going to give you 1. And add up all that. That's going to give you the total number of teams that have at least 3 freshmen. I guess here it goes. We still have to wait. This first one is 900. Those are 900 teams that have the 3 freshmen. There's 150 teams that have 4 freshmen and 1 non-freshman. And then the last one. There's only 6 teams that have 5 freshmen in them, and you add it all up, it's a total of 1,056 teams that can be formed that have at least 3 freshmen. Last one, letter E. What's the probability that the team they select has the at least 3 freshmen? That's the same thing that we did on C. The probability will be your number of options that have at least 3 freshmen, which we just did, 1056, out of the total number of teams. Remember at the very beginning, letter A, total number of teams available, possible. Just divide that, and that's going to give us our final answer. Divided by 4368. Round to 3 decimal places. 0.242. And if you don't round right, it's going to mark it wrong, and that's too bad. Only type the 3 digits to the right of the decimal. Pause the recording.